Hello. How are you? Hello. How are you all doing? Today, we'll be talking about Prolog, um, which is yeah. Hello. How are you all doing today? Today I'm going to be talking about logic programming, specifically be talking about Prolog, and let's get started. So what is logic programming? Well, logic programming it's like a set of sentences in a logical form, uh, expressing facts and rules about like a public domain. Um, you have like rules where you have a head, if body. For example, the head H, um, if body is true and body 1 is true and body 2 is true, and how many whatever bodies there are. There could be multiple, or there could just be one. Um, and then there are facts, which are basically uh, rules without a body, so they're just stating like a fact. Yeah. So then um, examples, of course, are Prolog, uh, ASP answer set programming, and then data log. So then, what is Prolog? Well, Prolog is a declarative language. Um, it again is it's a logical programming paradigm. So it uses facts, rules, relations, queries. So what it means by relations is that um, basically, given a query, Prolog will attempt to find uh, a retribution or mistake of um, a negated query, so an opposite of the original query you search. And if that is found to be false, then uh, it continues with the original query uh, with the found instance. I could talk about more about that later, but yeah. So Prolog is actually one of the first and most popular uh, logic programming languages. It and yeah, it's primarily used for databases, database searching, voice control systems, pattern matching. One of the uh, best examples of uh, this language is that it has been used with Watson, uh, basically a supercomputer that's capable of answering questions. And yeah, it won in a game of Jeopardy, which I might it might seem unfair, but that's how it is. Uh, so intro into the language. Well, here's some what I meant about facts. Uh, where what this is basically saying is that John knows Greg, and that's a fact. That's stated basically. And then similarly, Emily knows John, and Greg knows John. Uh, what's important to note up here is that what's is saying right here is that John doesn't know Emily just yet, because it's not stated, because Emily's coming first, so that Emily knows John, but John does not know Emily since that's not been stated anywhere here. Um, and this would be something like a rule where you have uh, the rule acquainted, x, y, which are variables because they're capitalized. Any capitalized letters in these parentheses are considered, or in fact anywhere in the program they're considered variables. So you have to be careful about the cases of letters. And what's this saying is if x and y are acquainted, if and only if um, x knows y and y knows x. Uh, yeah. So then there's also arithmetic operations, but they're not Prolog's strong suit. So let's get right onto the example. Um, Here's a Swish. It's a pretty useful tool. Um, it's both a compiler and a kind of text editor all in one. So here, like what I was saying is, you know, uh, you could. So basically, Prolog is used with, or it's computed with queries. So um, typing in this, we get in that does Greg know John? Yes, that's true because we already have it up there. Um, and then you could do the same with Emily and Greg and things like that. And uh, same as when it's not true, like Greg and I don't know Bonnie. There's no Bonnie, so Greg does not know Bonnie because it's not been stated up here. And we could look with uh, to see if people are acquainted. Let's try Emily and John. It's false because Emily knows John, but John does not know Emily, so in that way they're not acquainted. And then we also have things like um, we could also do things like with the weather. Um, Here I want to kind of showcase impure predicates, so like things that you don't have to add. So if you want to find like a city, um, and we don't care about like the season or whatever, we just want to find when it's chilly um, in every city. Right now I only have two, but that's all I have. So right here we could see that there's chilly in Chicago, and then chilly is also in Seattle. So then we have that, and then remember over here I have an example of a recursive function where we also use kind of like this is the list, um, kind of denoting that this is the head, this is the tail, and yeah, and members are already in a function, but I already kind of make it here anyway. Um, where member just finds uh, the variable x in your list. Uh, so yeah, I already have queries typed out, so I'm gonna type that all out at once. Uh, so here's the variable, here's a list. That's the member function, and we get that that's true because 3 is in fact in the list. We do 9. That is not. Oops. 9. That is not in the list, so it will be false. So that is my example. Um, and so with the remaining 2 minutes, I'll just highlight some of the features I have with Prolog. Prolog has these logical variables, which basically they're variables that are initially undefined or unbound, but may get bound to another value or logic variable in the future. So that's the same thing as the underscores, where they don't necessarily have to be there until they could be defined later. And there's shared variables, um, unification, uh, which basically substitutes variables in terms so that they're identical. So you could have uh, multiple rules that are the same, and they when you query that rule, then you get multiple answers depending on if they become true. And then you have lists, Recursion, of course, you've seen that. Backtracking is a good feature in Prolog because um, it explores all possible uh, alternatives until a solution is found. Um, and if not, then it is a complete failure. And yeah, that's basically um, the gist of Prolog. Uh, I hope you enjoyed my presentation, and uh, see you later.